Hi and welcome to Cherry Pie Math. This video is going to go over graphing proportions, getting that data into the graph and then taking that data out of the graph. Before we get started, you need to know what a coordinate grid is, so like this thing with the x and the y, and you need to know what a unit rate is or a constant proportionality is. If you don't know what those things are, review them, and if you do, then you're good to go. So I have three pictures of graphs here. One of them is not a proportion, so go ahead and pause the video and see if you can tell which one is not a proportion. Okay, if you said the middle one was not a proportion, you'd be correct. The reason is, even though all three of them are lines, it needs to go through that point in the middle that we call the origin. If it doesn't go through the origin, it can't be a proportion because it's representing an imbalance between the two things. And that's going to be a really big deal as we go through the rest of this video. So I have this graph. So the x-axis here is representing time and the y-distance is representing the distance in miles. So the independent variable here, when we talk about independent or dependent, remember that independent variables are the ones that determine the dependent. So the distance does not determine the time. The time spent driving determines the distance. And so in this case, the independent variable is always x, by the way. It's time. And then the dependent variable, which is always y, is distance in miles. So I guess that kind of answered that next question there. So x represents time, y represents distance. And this is just a standard practice across mathematics. The x-axis, the horizontal axis here, is always going to be your independent variable, and your y is always going to be your dependent variable, because if you switch them up, it makes it just annoying and confusing. So let's take a closer look. So what would 3, 210 mean in terms of the graph? And how do we know? So just a quick review. So if you have a point like this is in the form x, y. So that means I look for 3 for the x value, and I look for 210 for the y value. And where they intersect, that's going to be the point 3, 210. So in this means that it's been 3 hours, and it's traveled 210 miles. And I know because that's the corresponding number on the axis. So the 3 is on the x-axis, which means it has to represent time. The 210 is on the y-axis, so it has to represent the distance. Why does it go through 0, 0? Because that's the origin. When 0 time has passed, 0 distance has been traveled. So remember, because in a proportion, it's a ratio. They are integrated together. One can't go anywhere without the other. So it has to be 0 on both sides because nothing of one part would mean nothing of the other. So let's think about how fast our car is going then. So let's think about how we normally measure how fast a car is going, and at least in the United States, we measure it in miles per hour. Now, it's not miles per 3 hours, and it's not miles per 2 hours, it's miles per 1 hour. So I'm really just looking for what number would go here. How many miles have I traveled in 1 hour? So at 1 hour here, I've traveled 70 miles an hour. And that's the biggest giveaway, is how, because it's a unit rate in a proportion, as long as the bottom is 1, that top represents the unit rate. So in this case, I'm going I'm going 70 miles an hour, because at 1 hour, it's traveled 70 miles. So it's my unit rate. So let's take a look at a different kind of graph. So this one is not a proportion. And for a similar reason to what we saw before, it doesn't go through 0, 0. So it doesn't go through the origin. So what's different about this graph compared to the last one? So first it's headed downwards, I guess, but that actually has nothing to do with the proportion. It can be up or down. So that's like not important. But it also doesn't go through origin. Like we just said. So on a graph, we will often see x, y. So kind of like how I said before, that means we go x spaces horizontally and y spaces vertically. So if I see like 2, 5, that means I go 2 this way and I go 5 up. Or if I say like -3, -7, that means the negative means I go the opposite direction. So that would be negative. I would go 3 spaces left and then I would go down 7 instead. So the positives indicate right and up respectively, and the negatives represent left and down respectively. A proportional graph will always go through 0, 0 because it means that 0 things from the independent variable means 0 things from the dependent variable as well. So let's take a look at those two graphs then. I have them copied over here. So what's special about x equals 1? It's going to represent the unit rate. So here's x equals 1. So there it is there. There it is there. X equals 1 is where we find the unit rate. Kind of like how I said before with that example of the 70 miles per hour. That's going to be my unit rate because the bottom is only 1, right? But in this one, even though the bottom is 1, because it didn't match up at the 0, 0, it's hard to tell the difference. Like here, right away, you can tell it's 0 to 70. That's the only change. But here we go from 0 to 5, but then we're kind of going down as well. And that's hard to tell. You could find the rate, but it would basically mean you have to move it down here, copy it down here, and then find the unit rate. And then find it right there, right? So that's something you'll do in future years, especially when you're studying y equals mx plus b in 8th grade. But x equals 1, if the line goes through 0, 0, is going to be where you find the unit rate. Just super easy right off the bat. So some things to remember. If you have a table and you're looking for the proportion, you want to make sure that y divided by x is the same for the entire chart. So if I have a chart like this and I have like 3 and I have 5, I would do 5 divided by 3. But then if I had like 9 and 15, I'd have to divide those and make sure that they match. Because if they didn't match, it wouldn't be proportional. But if they do match, then the proportion, the unit rate or the constant of proportionality. We just went over graphs. It has to be a line that goes through the origin 0, 0, and then 1 r is the unit rate. So basically wherever the line is at x equals 1, that's going to be your constant of proportionality. If you have an equation, if it looks like y equals kx, where k is a number, so like y equals 4x, then that's going to be your constant of proportionality, and you know that it's proportional. But if you have like y equals kx plus b, I guess, or y equals mx plus b, that's not a proportion because you've shifted up or down that line. So it has to just be y equals kx. And the words, you can test it for proportionality if it says for each or for every, because in a proportion, you're changing it at the same rate. You can't have one thing changing and the other one not. Anyway, I hope that helps you to understand what the differences are between those different forms and how we can find those proportions. And especially with graphs, just know that it's proportional if it goes through 0, 0, and if it's a line. And then if you want to find the unit rate, it's just that number at wherever x is equal to 1. So I hope that helps and good luck.